Lecture notes 22, talk about the quadratic equations. So when we solve quadratic equation, a guarantee method is to apply quadratic formula. All right, so a quadratic equation looks like this. We have some A, B, C, some numbers. The variables are, we have x raised by square, x. So in this case, B can be 0, C can be 0, but only A cannot be 0. Because if A is 0, we don't have a square term. We don't have x squared. They wouldn't make a quadratic equation. So what is the relationship between quadratic equation and quadratic function? Right, because when we talk about function, let me write here. We write that as f of x equals to ax squared plus bx plus c, right? This is just one of these three forms. We have a vertex form, we have factored form, and we call this a standard form of quadratic function. So you see here equals to 0. So that means the function value is 0, right? Or you can think of this as a y. We have x-axis, y-axis, we have xy plane. So y is 0. If y is 0, remember the points. When the y value is 0, we call x-intercept. X-intercept. So solving these equations, especially this is a quadratic, we're looking for x-intercepts. Right? Quadratic functions, we have upward parabola. If A is positive, we have downward parabola if A is negative. So solving the equation when the function value equals 0 means we're looking for, it's just as an example, okay? We're trying to find those 2 points. Same thing for this, right? So if it's possible. Sometimes it may not, the graph of the function may not cross the x-axis. If it does, it may be we may have at most 2 points, 2 x-intercepts, or we may have one. Maybe a graph looks like this. Maybe a graph looks like this. Okay, we may touch the x-axis only once, or we may have. Let me change green color. Or the graph may go this way. You know, it never touches x-axis, or may go this way. We never cross x-axis. So this means this equation could have 3 kinds of solutions, right? So the first solution would be, we do have 2 x-intercepts, right? So 2 solutions. Then we may have 1 solution. Then we may not have real solution, so no real solution. But we have 2 complex solutions. So last class we talked about the complex numbers, right? 2 complex solutions. So we have those 3 situations when we solve this quadratic equation. All right, we'll talk about the quadratic formula soon. But sometimes if this equation can be factored, or even before factoring, we always try to simplify the equation, right? If the terms have common factors, we like to get rid of the common factors. Right? If there are like terms, we like to combine like terms. So solving any equation, we want to make the equation first in its simplest form. So let's see this example. We have x squared minus 2x minus 15 equals 0. So this can be factored, right? We think about 2 factors of negative 15 adds up to be negative 2, right? Negative 5 times positive 3, indeed, negative 15. Negative 5 plus 3, indeed, negative 2. So we factored as 2 factors, 2 linear factors, x minus 5, x plus 3. Now use zero property, right? Zero property is saying if product of factors equals 0, that means each one can be 0, or maybe some of them to be 0, or maybe all of them to be 0. In this case, we just have a product of two factors. So we can see the first factor is 0, or the second factor is 0. Solve the first one, we move -5 to the right-hand side, or we add 5 on both hand side. We get x equals to 5. Do the same thing, we get x equals to -3. So we have two solutions. That means if we talk about the function, right? If we talk about the function, we could talk about the function f of x equals to x squared minus 2x minus 15. And then if we want to graph it, we will have two x-intercepts. One is 5. Let's see, this is 5. One is -3. Because x squared, the leading coefficient is 1, positive. So then in the future, so obviously this is y-intercept, right? 0, -15 is y-intercept, I see somewhere here. So our graph looks like this. It passes this y-intercept, passes these points. So that's the meaning of solving quadratic equations. We're basically looking for, when the y value is 0, looking for x-intercepts. All right, so in this case, we do get two x-intercepts. Or later on, maybe we'll call zeros or roots. Okay, depends on the context. Okay, that's this. Quadratic formula. So if sometimes it's difficult to factor the equation, or maybe it's impossible to factor the equation, so we could have this solution. So the condition, the setup is this. We have to write the equation in this form. Write the equation in this form. I lost my pen somehow. So first we write the equation in this form. We have ax squared plus bx plus c. We call the number before x squared a, we call the number before x b, we call the number itself c. So once in this form, we say, okay, the solution of this equation have this formula, which is called a quadratic formula. So we just plug in -b plus minus square root of b squared minus 4ac divided by 2a. All right, this one here is important, right? This tells us, so because we have a square root, if this one is a perfect square, so b squared minus 4ac, if it's a perfect square, think about this as a 4. Square root 4 is 2. In that case, we have two rational solutions. Right? Or if this one is not a perfect square, think about this as a 3. Square root of 3 is an irrational number. So we have two irrational solutions. Or this one may be 0. If this one is 0, we're left with -b over 2a. We only have one solution. Or maybe this one less than 0, which is a negative. Square root of a negative number, which is an imaginary number, right? Not in real number system. So we also have two solutions. So we'll see some examples. Let's see this one. So this equation, no, I think this is missing as equals to 0. Okay, this has to be equals to 0. Otherwise, it's not an equation. So this example, we have x squared minus 2x minus 15 equals to 0. So let's figure out a, b, c. A is a number before x squared. By default, that's 1. B is a number before x, which is -2. C is the number itself, which is -15. So we just plug into the quadratic formula. -2 plus minus square root of -2 squared minus 4 times a, 1 times c, -15. Negative 2 become positive 2. 2 squared here is 4. Minus 4 times 1 minus 4. Minus 4 times minus 15, positive 60. And so we'll get a square root of 4 plus 60, which is 64. Well, square root of 64, we know it's 8. Right? So we have positive 2 plus minus 8 divided by 2. So we have two solutions. One is a 2 plus 8 divided by 2. With a 10 divided by 2, we get 5. Another one is a 2 minus 8 divided by 2, which is a negative 6 divided by 2, which is negative 3. Right? Two solutions, same as before. Two rational solutions, that means this one can be factored. We already showed earlier, this can be factored as x minus 5 times x plus 3. Right? So one way we factor, if we know how to factor, we factor it, we get two solutions by using zero property. Another way is we figure out A, B, C, we plug into the quadratic formula. Let's see this example. This example is x squared minus 3x plus 4 equals to 0. So this one, there's no way to factor this, right? The middle term is negative, so 4 has to be factored as 2 negative. It could be either -1 times -4 or -2 times -2. But then -1 plus -4, that's -5. -2 plus -2, that's -4. But the middle term is -3. So that tells us this cannot be factored. So let's use the quadratic formula. So figure out A is 1, B is -3, C is 4. Plug in negative -3, plus minus, because this is B, right? Plus minus the square root of B squared minus 4AC. All right, I suggest you in the very beginning, write down the formula a couple of times to remind yourself, all divided by 2A. So plug in the values, -3 squared minus 4 times 1 times 4, right? Which will get a 9 minus 16. Well, 9 minus 16 is -7. So a positive 3 plus minus square root of -7, which imaginary number, which is we change square root of -7 to be I square root of 7. Okay, then this gives us two solutions. 3 plus I square root of 7 divided by 2, or 3 minus I square root of 7 divided by 2. So usually we write as A plus IB form or A plus BI form. Right? So we call those two conjugate, because they differ only by the sign. One is plus, one is minus. They're conjugates with each other. Oops, missing A. So complex solutions come in pairs. Just like irrational solutions. If it's irrational solution, also come in pairs. So I have two solutions for that one. Now we have 4 here. Let's use quadratic formula for, and also let's try if it's factorable, we can factor. So the first one is A equals to 1, B equals to 1, C equals to 4. Let's write down the formula. Negative B plus minus square root of B squared minus 4AC divided by 2A. All right. So B squared minus 4AC, we call discriminant. All right, it has a name because it's important. Let's calculate B squared minus 4AC first. So B is 1, so we get a 1 squared. Minus 4 times A is 1, C is 4. So we get a 1 minus 16, which is negative 15, right? So when we square root, we'll get a complex number, we get an imaginary number. So x equals to negative b, which is negative 1, plus minus square root of negative 15. Once we get to this point, we know we have two complex solutions. 2 times a is 2 times 1, 2. So we have negative half plus minus I square root of 15 divided by 2. Right? Square root of 1, negative 1 is I. So I have two complex solutions. The real part is negative half. The imaginary part are conjugating with each other. One is positive, I square root 15 divided by 2. One is negative, I square root 15 divided by 2. Well, let's see this one. A equals to 1, B equals to 4, C equals to 1. So x equals to negative b, negative 4 plus minus square root of 4 squared minus 4 times a times c, all divided by 2, 8, 2 times 1, right? So we have negative 4 plus minus, well, we can calculate the discriminant on the side. 16, 4 squared is 16. 16 minus 4 times 1 times 1, which is just 4. So we get 12. Now, square root of 12, remember this is the square root of 4 times square root of 3. Square root of 4 is 2. So we get a 2 square root of 3, or 2 radical 3. So plus minus 2 radical 3 divided by 2. Negative 4 divided by 2, that's negative 2. Plus minus 2 radical 3 divided by 2, which is radical 3. So we have two irrational solutions. Right? One is negative 2 plus radical 3, one is negative 2 minus radical 3. 2. So irrational solutions also come in pairs, also as a conjugate. Let's see 3. A equals to 3, B equals to negative 2, C equals to 3. So x equals to negative 2, positive 2, plus minus negative 2 squared 4, minus 4 times A times C times 3 times 3. All divided by 2 times 3. Well, let's calculate again on the side. So I have 4 minus 3 times 3, 9. 4 times 9, 36. So get negative 32. Well, square root of negative 32 equals to I square root of 32. Well, 32 is 16 times 2. So we can split square root 32 as square root 16 and 2. Square root 16 is 4. So we get 4 radical 2. So this one equals to 2 plus minus I 4 radical 2 divided by 2 times 3, 6. Well, let's leave 2 here, but we can simplify it. 2 divided by 2 times 3, 2 over 2 becomes 1, so we get 1/3. Plus minus I 4 divided by 2, that's 2. So 2 radical 2 divided by 3. So we got a 1/3 plus I 2 radical 2 over 3. 1/3 minus I 2 radical 2 over 3. Okay, last one, 4. Again, we figure out A, B, C. A is 12. B is negative 4. C is 5. So x equals to, if you don't remember, try to write down a couple of times. So this formula can register in your head. B squared minus 4 AC divided by 2A. So we just plug in negative B, negative 4 become positive 4, plus minus square root of negative 4 squared, 16, minus 4 times A, 12, times C, 5. All divided by 2 times 12. Well, let's calculate the discriminant first. So I have 16 minus, let's do 4 times 5 first. 4 times 5, 20. 20 times 12, 240. Then also get a negative number. We get a negative 224, right? Because 224 plus 16, that's 240. So negative 224, we get a complex number again. So we write as I square root of 224. Oh, this, I wrote it wrong, 224. Now let's see how to simplify square root of 224. So I'm going to use short division. So I make this sign. I put 224 inside. I think, okay, this is an even number. So that means I can divide it by 2. 2 divided by 2, I get 1. 2 divided by 2, I get 1. 4 divided by 2, I get 2. Again, 112 is a even number. I can divide it by 2 again. So what do I get about? 1 is smaller than 2, so I take 2 digits, 11. So I should put a 5 here, right? Because 2 times 5 is 10. Then 10, subtract from 11, I have 1 left. Then I see I have 12, so that's 6. Right, 2 times 56 is 112. 56 again is an even number. I multiply by 2, I get 28. Then I divide by 2, I get 14. Now I see I have 2 times 2 times 2 times 2 times 14. So that means 224 can be written as 2 raised by 4 times 14. Well, 2 raised by 4 is 16, right? Times 14. So that means this number I can write it as I for square root of 14. Right? Because square root 16 is 4. So now let's come back here. So we have 4 divided by 2 times 12, that's 24. 4 divided by 24, so that's 1/6. Plus minus. Then I have here, I have for this one, I have 4 2. 4 divided by 24, 1/6 again. So I get a square root of 14/6. So the I can put it in front or can put it after. So also I have 2 complex solutions for this equation. Okay, so I want to go back, talk about another method called completing squares for one of the questions. Because basically there are 3 methods to solve quadratic equation. So one is called factoring, if it's possible to factor the equation. One is called using quadratic formula, or another one is called completing squares. Because quadratic functions can also be written as in its vertex form, x minus h squared plus k. If we can write a quadratic function in this term, in this form, h comma k is a vertex. What do I mean by the vertex? Remember, if a is positive, I get an upward parabola. If a is negative, I get downward parabola. So those lowest point or this highest point called a vertex. But in this picture, we call this minimum. In this picture, we call maximum. So both of them together called a vertex. So sometimes it's good to write it as a square. So which means we want to complete a square. Complete a square. So how do we do that? So we move positive 1 to the other side, becomes negative. So now I have 2 terms, x squared plus 4x. So I take 4, take the number before x, which is 4. I divide by 2, which I get 2. Then I add 2 squares. So I add 4 on both sides. Then x squared plus 4x plus 4, if you remember, that's x plus 2 squared. So by doing this process, by taking the number before x divided by 2, then add 2 squared. So this is 2 squared, right? This number could be any number. You just add a square on both sides. Then you make x plus or x minus the number squared. Then equals to 4 minus 1, which is 3. Then let me change my color. So I have perfect square on the left-hand side. I can square root. When I square root, I get a positive, negative 2 values. Square root cancel each other. So I get x plus 2 equals to plus minus square root of 3. So I move 2 to the other side, becomes negative. So usually we write this number first, negative 2 plus or minus radical 3. Remember, when we use quadratic formula, we'll also get this answer. So this is another method called completing a square. That's it. That's the lecture notes for 22.